Okay, now we're going to look at, we looked at the remainder theorem last time. Also, I gave back those half sheets. Here are the answers. Ask me for the half sheet if you need to. And now we're looking at the factor theorem. The remainder theorem essentially said if we wanted to find f of a value like -3, we can do that synthetic division, and whatever the remainder is, that would be the answer. The factor theorem then should make sense because it says if we do that same thing and we get a remainder of 0, then whatever that x value was that we used can be converted into a factor. And so the factors theorem says that a polynomial f of x has a factor of x minus k if and only if f of k equals 0. And so again, it's that x minus k thing, but then it's k that we do as synthetic division. So just a little reminder of these relationships. So the factor is x minus k. If you do the division, you're going to divide by k in the version format x minus k. And if you're finding that remainder, you're finding f of k. And so then x equals k is a 0. So those are just all related concepts for these as we go. It is very desirable for us to find factors because if we find factors, then we can break a higher degree polynomial down until eventually it's like a quadratic, and then we know how to handle a quadratic as we go. So here's our next thing, and that is just to show that these are factors. So a common question would be either to show that these are factors or decide if they are factors. So since we're told to show that these are factors, our rule is f of x equals 2x to the fourth plus 7x to the third minus 4x squared minus 27x minus 18. And so the powers are 4, 3, 2, 1, 0. So they're in decreasing order, and every factor is accounted for. And we're going to show that x minus 2 and x plus 3 are factors. And I rewrote this one because I feel like that took up a lot of space, and that was difficult for me to look at. And then I also have to find the remaining factors, so the factors that are left. There's another dynamic here that we're going to use in this one, and that is if something is a factor, we can use that quotient as our new synthetic division kind of thing that we're going to do. So I'll color code this a little bit. If the factor is x minus 2, then x equals 2 is the 0 or the root or what I will do my synthetic division by. And then my coefficients here are 2, 7, -4, -27, and -18. I didn't write my -18 very well. And I'm still doing this full out and using 3 lines. I'll bring down my 2. 2 times 2 is 4. 7 and 4 is 11. 11 times 2 is 22. 22 minus 4 is 18. 18 times 2 is 36. 36 minus 27 is 9. 2 times 9 is 18. I get a remainder of 0, and I usually put that little bar there. Now, here's what that means to us, and I'm just going to remind you. This could be rewritten then as x minus 2 times, and remember this is 0, 1, 2, 3, 4, or 0, 0 is the remainder, 0, 1, 2, 3. So 2x to the third plus 11x squared plus 18x plus 9. Hopefully you agree that this cannot, you wouldn't want to try to factor that. Yep. It's an 18. It was an 18 that I didn't draw very well. Yeah. So now here's the beauty of this. When that remainder is 0, this is a factor of this original, but it's also a factor of this. Think about the fact that, you know, I want to factor out this x plus 3. So instead of dividing this x equals -3 into this whole original thing, I can just use what was the quotient of this, ignoring that 0, because that's not there anymore. So essentially, I know that this x plus 3 is a factor of that little piece. So my next synthetic division is going to be -3, and I'm dividing it into 2, 11, 18, and 9. Why am I doing that? Because I know it's going to be a factor. I could put it into that other one, but if I put it into this quotient, then I'll end up with my x minus 2 and my x plus 3, and then what's left here will be that the quotient of this synthetic substitution. So I'm enabling myself to make the power go down and down and down, and that's desirable to me because once this is x squared, then I'll be able to factor it further. So I can only do that if this was a factor, and it was, so that's what I'm gonna do in this problem because the remainder was 0. Yep. So I'll bring down my 2. 2 times -3 is -6. 11 minus 6 is 5. 5 times -3 is -15. Plus 18 is 3. 3 times -3 is -9. My remainder again is 0. This is my remainder. This is my 0, 1, 2 power. So I've already pre-wrote that as we were talking about it. And so now when I write this in factored form, I've got my x minus 2 from there. The blue writing. I've got my x plus 3. And then this gives me 2x squared plus 5x plus 3. Now, I'm told that that will factor, so I will let you use whatever method you like to use and factor that quadratic. I'll give you a moment to do it, otherwise I'll do it myself. So take a minute, see if you can factor that. So you're going to end up with x minus 2 and x plus 3, and then 2 sets of parentheses. So using whatever method, are you ready to hear it or see it? Using whatever method, this is 2x plus 3. This is x plus 1. Does everybody agree with that as we go? And so you just want to make sure that you can kind of give the answer that you need to. Now, this one is done, and that's what we were asked for, finding the remaining factors. So those are the remaining factors. I'm going to use this problem, though, to tell you the different questions you could be asked in a problem like this. And so I'm going to start by just rewriting it down at the bottom here. So f of x was 2x to the fourth plus 7x to the third minus 4x squared minus 27x minus 18. And so if we were asked to give the factors, they are this answer: x minus 2, x plus 3, 2x plus 3, and x plus 1. This is the factors, or write in factored form. So factors or written in factored form. If we were asked to find the roots or the zeros, we would set each of these equal to 0. X minus 2 equals 0. So x equals 2, negative 3, negative 3 halves, and negative 1. Okay? So just be careful of whether it's a factor or a root or a zero, the terminology that we're using. And we were told that x minus 2 was a factor. And so when we did the synthetic division, we divided by positive 2, correct? So we kind of do that different sign thing. So in this case, I was given those as factors. I could have been given them as zeros, and then just notice we would have divided by 2 and negative 3, and that's exactly what we did in this problem. Oh. Oh, this is maybe... Got it. Okay, so then our next problem is related. It says use synthetic division to show that x is a solution of the third degree polynomial equation, and use the result to factor the polynomial completely. List all real solutions to the equation. So you'll notice I not labeled this as 59. That is because it is 59, and if we didn't go over this one. There's none really like this in the notes, although I just talked about this. So if x equals 2 is a solution, when I do synthetic division, what am I going to divide by, 2 or negative 2? I'm going to use 2 to divide, 2. And 3, 2, 1, 0, what do I have to make sure I do when I do synthetic division? Add x squared in there. So my coefficients are 1, 0, negative 7, and 6. What should my remainder be when I do this problem? It should be 0. And so let's take a minute and see. I bring down my 1. This is 2 plus 0 is 2. This is 4 minus 7 is negative 3. This is negative 6 plus 6 is 0. So that means if I was going to write that right now in factored form, what is this factor going to be? X minus 2. And what is the rest of this? X squared plus 2x minus 3. And let's see, it says to show that that is a solution, so we've done that. Use the result to factor the polynomial completely, and then list all real solutions to the equation. So they're leading us to believe that this is going to factor further. And, oh, this one we can factor pretty easily. What multiplies to be negative 3 and adds to be 2? It's 1 and 3. Right? I know, I keep hearing 2, but it's minus 1 and plus 3. So The answer to the first thing was to show that x is a solution. That's what we did right here, showing that the remainder was 0. The second thing we had to do is use the result to factor completely. And so this is factored completely. And what's the third thing we have to do? List all the real solutions. So solutions, and by the way, it says real solutions. So if that hadn't factored, and if that hadn't factored, do you agree you could use the quadratic formula? And so you can give an irrational solution that way, but if it's imaginary, you're asked for real solutions, so they wouldn't count, or you wouldn't include them if they were imaginary. But if they're irrational, you would still include them. So our solutions are when these factors are equal to 0. So x equals 2, 1, and negative 3. Oops. 2, 1, and negative 3. Everybody got that pretty well? Yes. And then I have another one from the homework. Verify the given factors, find the remaining factors, write the complete factorization, and list all of the zeros. So same thing, remember we kind of do that progressive division. What are you going to divide by first? Negative 2. And 3, 2, 1, 0, do we need to add any zeros or anything, or are we good? We're good. So 2, 1, negative 5, and 2. I bring down my 2. Negative 4 plus 1 is negative 3. 6 minus 5 is 1. Negative 2 plus 2 is 0. So I'll just kind of leave that. And then I can ignore this. And now I'm using this as my synthetic division row. What am I dividing by now? 1. And I'm dividing that into 2, negative 3, 1. Is everybody 100% clear on the fact that I want to use that quotient to do my next division? Because that's how I'm making it more and more factored. So I bring down my 2. 2 times 1 is 2. 2 minus 3 is negative 1. Negative 1 times 1 is negative 1. 0. By the way, what's that factor going to be? 2x minus 1 is the quotient of that, and so then that's going to be my factor. So there's my verifying. I just did that. So that was verify the given factors. Then I'm going to find the remaining factors. I did that because there was just this one extra factor. And I'll write the complete factorization, x plus 2, x minus 1, and 2x minus 1. Well, okay, remember for that negative 2, we had been told the factor was x plus 2, and then we used negative 2 to divide. Okay. What top one? This is the original thing. Oh, this? No, this I just broke down. So if I'd have, that would have been, I didn't write it this time as an intermediate step. I know now what you're asking. So that would have been x plus 2 times 2x squared minus 3x plus 1. As a matter of fact, you know, could we have factored that? Absolutely. So then, no, we know what that factors into that, because we did the next synthetic division for that one. So this is that next part, the write the complete factorization is right there. And then list all of the zeros. Zeros, what are they? Okay. And do you think people get these wrong? Yes, I asked for the factors, I get the zeros. I asked for the zeros, I get the factors. So if you want to just make sure you don't make that mistake, then be very careful. I am giving you the rest of the time to work. Homework 2-3 will be due on either Tuesday or Wednesday next week. What day do you want it to be due? What day? Tuesday? Okay, and so I will just add a slide and I will say homework 2.3 is due Tuesday, which I think is 10:25. Well, I'm wrapping this up right now, so quick. And here are some messages from your classmates. Anybody else? Okay. All right. So now we're having quiet work time.